Hi, this is Mr. Bear, and I'm going to be showing you how to do 1998D, free response equilibrium. So this question is really dealing with Le Chatelier's principle. It's asking what's happening to the concentration in particular of carbon monoxide. So I'm going to put a little box around it just to remind myself I'm looking at what happens to carbon monoxide after a various number of stresses are added to the system. So in 1998A, it's asking what happens when you add additional hydrogen to the equilibrium and the mixture is at constant volume. So if you add more hydrogen, you're bumping up its concentration. What that does is it shifts the equilibrium to the left. The reason the equilibrium is shifted to the left is because now that you have more on this side, it's going to have to produce more of these products to lower its concentration. You're imbalanced, essentially. So since you're having a shift to the left, that means that you have to consume more carbon monoxide to produce carbon and water again. So what happens to carbon monoxide? Carbon monoxide decreases. And what you would say is that it shifts to the left and must consume carbon monoxide to create more reactants, since you are imbalanced and you've obviously added more hydrogen, which is a product, so you shift it to the left. All right, now on B, it says the temperature of the mixture is increased at constant volume. So what I like to do on this one is I like to write out the equation. And when I write out the equation, I'm going to put energy as part of my equation. I notice up here in the top it says that the change in enthalpy is positive 131. That means that energy is going into the system. It's entering, so it's endothermic. Since it's endothermic, energy is not being released. If it was released, it would be negative. Energy actually acts as a reactant, and I can use this to help make a prediction about what happens. So if the temperature is increasing, that means I am going up here. And if I increase the amount on this side, I'm going to produce more products now, so I'm actually shifting my equilibrium to the right here. And when I shift my product, or shift the equilibrium to the right, CO increases. And your explanation would be because it's endothermic and that the products are favored in an endothermic reaction. The reactants are favored in an exothermic reaction if temperature is increased. I didn't write that down, but you would have to actually write it down to get full credit. C, the volume of the container is decreased. Well, it's important to remember the relationship between volume and pressure, because that's going to help you answer this question, because they may toss out you volume as in this problem, or they may toss out pressure. Now, it's important to remember, if you look at PV equals nRT, that these two variables, pressure and volume, are on the same side of this equation. That means that they're inversely related. That means if I'm decreasing my volume, if this is going down, then my pressure is going up. So if the pressure is going up, let's look at the chemical equation. What will happen is it'll favor to the side in which it decreases the total moles of gas. So this time I'm actually writing out all the states of matter. And since carbon is a solid, it's not a factor in changing the pressure. So I'm only looking at the moles of the reactants versus the moles of the products. There's no number in front of water, so that means it's 1 mole of water. And then there's 1 mole of carbon monoxide and 1 mole of hydrogen. That gives you a total of 2 moles on the product side and 1 mole on the reactant side. That means when you increase the stress and increase the pressure, it's going to favor the side in which you produce less moles of gas to drop the pressure again. So it's actually going to shift to the left. It's going to favor the left side. And since it's going to favor the left side, what's going to happen is you are going to decrease the amount of carbon monoxide present. So CO decreases in this situation because it's going to shift to the side with less moles of gas. Then the last question, there's no change at all. The reason there's no change at all is because if you're already at equilibrium, changing their state of matter, a physical change, is not going to have any effect at all, and you would want to write that out as well. So the verbal explanations that I gave for the answers for each of these, you want to actually write down to get full credit on a question like this.